I'm Eric Toller, and along with my teammates Ryan, Devin, David, and Corey, we make up Team Shaggin' Wagon. For a little inside of background of our customer, it's Shagbark Mill. They're a locally owned mill, and currently right now they're producing nutrition and organic products all over Ohio. The process that we'll actually be taking a look at today is what their bagging system. Right now they bag popcorn and dried beans into 1 and 2 pound bags. And this can be found at Athens, the Athens Kurgers, Casa, the Burrito Buggy. A lot of people actually really depend on them. For a project overview of our project, this is their current system right now. What you can't see, there's a hopper above that, and it will be filled with their beans or their popcorn seeds, and then they'll release a valve so it will fill up this PVC pipe. And to keep that from the beans from spilling out everywhere, they actually have to hold it with a hand at the bottom of it. So that scale right there they'll use to do the weigh each bag, and they'll let it out and it'll fall through. And it's very tedious, and it has to be calibrated and ample weigh every single bag, and we hope to actually change that. Their project concepts, which are original, after we met with Shagbark, got their customer needs and their specs, we were able to come up with some concepts. And they all kind of have their different unique abilities. Some were weighed by mechanical, or some were weighed by volume, some were weighed by weight, some were all electrical, all mechanical, or some had both. And to go to the next slide, to narrow that down, we did a volume test, and this would eliminate how we were. This will tell us what we were able to do if we could measure by volume at a high enough accuracy to the density of the seeds. And from our test results, we were actually able to, we had a variation in 0.02 pounds through various tests. Our initial design here, as you can see, we got our plates are all stainless steels. We had 2 adjusting screws that will actually raise this adjustment platform up and down so we can change the volumes between 1, 2, and an option of 5 pounds. Linear bearings, and the problem is with this, it was very expensive, very low value to cost ratio, about $2,300. Simple of this how to use, so basically the slide system will be moved forward and backward by the operator. So when the slide system's moved backwards, it'll line up underneath their hopper as it is now, filling up our controlled cylinder, and then once that's filled, you'll pull it back and it'll line up with our funnel that will go out down into the bag. Also with going back and forth, it'll actually close off the hopper, so when you pull it forward, it closes off the hopper, that way beans don't spill out everywhere. One of the techniques that we used to assess our part was a value engineering technique, and we will break down each part and component and assess like what their functions are. Ideally, we want parts to have multiple functions. That will give us the cheapest, most simplistic design. And by doing that, we changed a lot of materials to plastic, which are FDA compliant. Changed from linear slides to T-slot slides, and 80/20 aluminum for our frame. Pareto analysis, this is a before and after. So before is the one we did before the value engineering, and this breaks down parts and compares it to the overall cost of the design. And after we did the value engineering technique, we got our lower and upper adjustment platforms. As you can see, it was $600, and we got it down to $279, along with our linear slides, which were $404, and we saved about $150 with that one as well. The next few slides are FMEA results, and this we look at our parts and see like which are going to have the highest risk of failure. And our first one is our bean jamming and crushing. We didn't want, when the slides are going back and forth, if a bean was to fall off to the slide and get jammed, just ultimately ruin the system. We did a test. Here's a photo of it, and we were able to give an example of what it would be like in the real system. We put some weight on top of it, and we ended up getting the risk priority number from 63 down to 27. Our next was frame failure, and we thought this was going to be an issue, not necessarily to fail, but we wanted to assess it just to make sure if in case it did happen, and we got it down from 27 to 9, so it shouldn't be much of a risk. And the last one is our improper adjustment. So whenever we're raising up and down the platform for to calibrate between 1 and 2 pounds, for instance, we don't want, if one side was lower than the other, it wouldn't adjust properly. And we can get around this with some operating training, misuse, mishandling. But we weren't actually able to run a test on this yet. We were looking for a little bit more funding before we were able to do this. One of the biggest things you have to do when building something, especially for someone else, is safety. That's one of the biggest concerns. And for our project, we think the biggest operator safety concern is going to be their pinch points. Because if the system's moving back and forth and they don't know what to do with their hands or want to reach in and it can pinch. But we think with we made it very, with the ergonomics, we were able to take a look at it. It's very safe. There's a handle on it for the slide system, and the other hand could be occupied, so they wouldn't have the instincts to want to grab anything they shouldn't. The next step after our design for safety was to simplify this. This will help narrow down some of our safety concerns. And like I said before, we used a plastic instead of stainless steel, which is very easy to manufacture. It's going to help us out with costs and a lot of time. Used pre-manufactured 80/20 aluminum for the frame post, and that helped out as well. Critical to quality, it's after assessing, simplifying it, we were able to see what the most critical part to make a good quality product was. And for ours, it's going to be the tolerances, the parts that require high tolerances. For instance, like the slides are moving back and forth. If they're not tolerant at the right, they will get stuck or get jammed or be loose or move. The whole positioning of the funnel and the hopper that connects to the bean cylinder is very important. If that's not at the right dimensions, the whole system will fail. And after this, we were able to come up with our final design through a long, much needed process. And I say long, it was very long. All the plates are FDA compliant. We switched from our original 2 adjusting screws to just 1, and we think that'll actually work. No bottom plate now. We're actually going to bolt it down, which saves us a lot of material cost. And T-slot slides, and as you can see, our cost is $1,600. We saved almost $700 going through this process. Here's a list of our bill of materials, and listing off some of the significant ones based on price would be our lower and upper vertical platforms, our T-slot slides, and what was the other one else? The vertical adjustment rod. Those 3 take up almost about half of our bill of materials. So those 3 right there are definitely of concern, but we feel good about our price right now. Here's a look at our schedule of what's up next. Our deadline is March 18th. And it seems like a long time away, but we actually have a lot to do. And so ME 1010, this is gonna, you guys should make a schedule. And this starts schedule from ordering our materials and list all the way down to we actually will assemble the prototype, which we'll show you on March 18th. And in conclusion, once we get the design quality down, the manufacturing plan, and get some of our test results confirmed, we'll be able to get our budget approved, and from there actually start building this thing.
Thank you. Again, having someone operate the projector and free you up to focus on presentation.
Yes.